Good day, doctor. Our group have chosen titanium hinge bracket production with additive manufacturing process. So first of all, what is titanium hinge bracket? Titanium hinge bracket is a structural connector between fixed and rotating components. It is commonly used in mechanical housings, landing gear doors, and aircraft control surfaces, where titanium hinge brackets have its properties where it must withstand cyclic loading and a combined tension, compression, and bending properties. It also requires a high alignment accuracy and structural reliability. When it comes to titanium alloy, titanium with 6% of aluminum and 4% of vanadium is the best titanium alloy to produce a hinge bracket using additive manufacturing. It is because it produces high strength to weight ratio, excellent corrosion resistance, and superior fatigue performance. Titanium hinge bracket is manufactured by conventional processes such as forging, machining, drilling, milling, and surface finishing, which subsequently gives some limitations such as high material wastage, long production time, and high production cost. And it also difficult to produce complex internal features. Moving forward, titanium hinge brackets is produced by using advanced additive manufacturing, especially laser powder bed fusion process. Laser powder bed fusion process involves several processes such as layer by layer fabrication using the titanium powder, and selective laser melting is done by customized CAD models. This additive manufacturing process, especially laser powder bed fusion process, provides a lightweight component and it enables to produce complex geometries with internal features, and it reduces the wastage of material where it efficiently increases the utilization of the materials, and it enhances stress distribution. Additive manufacturing also assists in integrating the topology optimized structures. However, this laser powder bed fusion also provides some challenges in the titanium hinge bracket manufacturing and production. There are some issues caused such as poor surface integrity, dimensional inaccuracy, and microstructural inconsistency, where it also produce defects such as porosity, keyhole pores, and high surface roughness, which significantly reduce the fatigue performance and affects the mechanical properties and strength of the component. It is mainly caused by improper process parameters such as laser power, scan speed, and layer thickness. Next, I would like to explain on the role of quality and lean management tools in the production of titanium hinge bracket. First of all, Kaizen promotes small, continuous and incremental improvements in the production of titanium hinge brackets. Kaizen also encourages the involvement of employees at all levels, and it helps to build a culture of problem solving and accountability. It supports a long-term process stability in the production line. Gemba Works enables the data-driven decision making, and it helps to support a cross-functional communication between the team and their management. 8D problem solving method helps the team and the management to identify the root cause systematically and help us to find a way for a permanent corrective actions. Whereas Kanban is a visual tool to manage work in progress, and Kanban ensures that the production matches the actual demand. Thus, this can prevent the overproduction and bottlenecks in the production line. As we connect it to the production of the titanium hinge bracket processes, Kanban improves the flow between the printing, heat treatment, and post processing. Next, Pokayoke is a mistake proofing system where it prevents the human errors before the defects occur. And Pokayoke is suitable for high precision manufacturing as it provides instant feedback and physical or digital constraints. Last but not least, failure modes and effects analysis. FMEA is a proactive risk assessment tool which prioritizes risk based on severity, occurrence, and detectability. FMEA helps the management to identify the potential failure modes before it is proceed to production.
Good day everyone. So I will now continue to present the process overview of titanium hinge bracket. So for every product, we will start from the design stage. So this one also same, we start with the 3D model designing of titanium hinge bracket. Then after that, we continue with topology optimization. So we using finite element analysis, which we normally call it FEA, to remove the non-lock bearing material, which help to reduce the weight of the final product. Then after that, we continue with the support generation. So some support structure will be designed to prevent the part from wrapping under the high temperature of laser. Then after that is the preparation of powder, the metal powder, which is one of the most important step. So we need to ensure the particle, the density, and also the flowability of the metal powder is suitable to ensure the after that the smooth of the melting process. Then is the after all the preparation is done, we before we start the printing, we need to do some setup on the machine. So we should ensure the inert atmosphere during the melting process. So we need to input the argon gas to reduce the oxygen. So this help to prevent the titanium, which is very uh, sensitive from oxidation. Then after that is we can start printing the LPF printing. So the laser will melt the powder laser by laser. Okay, once the printing process is done, so we will do some post processing step to ensure the product is meet the standard. So it will begin with the control cooling process inside the inner chamber to avoid thermal shock and oxidation. Then is the heat treatment. So for this product, we use the hot isostatic pressure. We call it HIP. So during this process, the high temperature and pressure will be conduct to remove the microporosity and also improve the material density. Then after all this strengthened part, we will continue with the part removal by grinding and also using some cutting tools. Then the CNC machine will be used for for the final dimension. We'll cut the extra material. Then finally, after all is done, we will do the quality checking and also the NDT, which is non-destructive test to ensure the geometry accuracy and also checking the is there any internal defects or surface cracking. Yeah. Okay, so after we understand the standard process flow of titanium hinge bracket by additive manufacturing, so we also need to ensure we know that we acknowledge the main quality challenge of during this process. So the first thing is the main challenge is the internal porosity problem. So this porosity normally caused by the gas entrapment or also lack of fusion during the laser scan. So this should be fast and should be overcome by us because this porosity will reduce the lock bearing area and lead to fail of the product. So the next challenge is the residual stress, which caused by rapid heating or cooling process. So if the heat treatment after the product done is not didn't conduct properly, so it will lead to warpage or even crack that misalign the hinge. Then is the surface roughness. So this will happen because there are some melt particle during the melting process will stick on the surface of product. So this roughness will significantly reduce the factory life and also the wear resistance of our product. Then next is the oxidation of the titanium. As we know, titanium is very high is high sensitive, so the oxygen contamination will make the metal become brittle and also unsafe when the metal oxidize. Yeah, that's all.
In this session, we established the theoretical framework for process improvement. We begin with the Kaizen, which use the PDCA cycle for continuous improvements change to eliminate waste. Complementing this is Kanban, a visual system that control workflow and prevents overproduction by managing WIP levels. To ensure qualities, we use Poka-yoke to mistake-proof the process, preventing humans error through control or warning mechanism. We also implement FMEA, a, a more proactive risk assessment tool that identifies the potential failure and prioritizing them using PRN scores. Finally, Gemba brings the management to the factory floor to observe the real value creating activities. Actually, our solutions are grounded in reality. If complex defects occur, we apply the AD methodology to identify the root causes and implement permanent fix. These tools set the stage for the specific application discussed in the section next.
Okay, so the first tool that we will apply in our process is FMEA, so failure mode and effect analysis. So what we do is that we look at every single process, and then we determine what are the possible failure modes that can occur in each steps. So, and then we rank them based on severity and occurrence, and then the detection, so how hard it is to detect. And then we list out the effects and the likely cause, and then we create a control tool to reduce those failure modes. So in this case, we have a study from Miller et al. From 2024 studying LPBBF using a similar process, and this is adapted one lah. So you can see here that how they list down all the potential effect and then the proposed quality tools. Okay, so next is Kanban. So basically, the way we apply in our process is that we define each process first. So for example, here we have printed, heat treatment, machining, surface finishing and inspection, and then we make slots. So for example, this machine can only have a maximum of 6 slots, or 4 slots, 2 slots, 3 slots, or 3 slots. And the main principle is a process cannot go forward if there is no empty slot in front of it. So here in my example, in the heat treatment, there is no empty slots. So all the processes behind, which is printed, cannot proceed. It must stop first to stop basically overload of the work, so that it doesn't create a bottleneck in the system, so that the workload becomes much more smoother and much more organized. So this is an example of Kanban board. So basically each product, each batch will get its own card, and it will move through the Kanban board, and it can only move if there's an empty space in front of it. Okay, so what is Kaizen cycle? So Kaizen cycle is based on the PDCA principle. So I'll give you the example from just now, which we use Kanban board. So first we identify the bottleneck using the Kanban observations. Then for the do, we apply weight limit and control release of the particular implants using the Kanban board. And then we compare waiting time and rework before and after improvement. So does this improvement have any have any significant effects? And then if there is significant effects, we apply the standard the effective changes towards the whole line. So this is done at other processes also, but just now we are shown through Kanban. And Kanban is one of it.
So my name is Shakir Ashraf bin Shari Azam. So for purpose improvement, Based on the challenge identified in LPBF process, several improvements are proposed to enhance process control, quality, product quality, and operational safety. This improvement focus on automation, real-time monitoring, and digital technologies. So the first is improvement AI-driven in situ monitoring. This system combines multiple sensor with machine learning to monitor LPBF process in real time. It can detect defects such as porosity, lack of fusion during the build, allowing immediate corrective action. This reduces material waste and improve build consistency. So overall, is an advanced error prevention system. So the second improvement, automated closed loop powder management. Manual powder handling often leads to contamination and consistent material quality. By automating powder handling and reuse, the system reduce human error, improve traceability, and enhance operator safety. This ensures consistent powder quality, which directly improve part performance and repeatability. Lastly, the final improvement is digital twins integration. A digital twins create a virtual model of the LPBS process using real-time data. It allows engineers to simulate process parameter, predict defects, and automate build before manufacturing. So this reduce trial and error, shorten validation times, and improve overall production efficiency. Thank you from me.
In conclusion, quality and lean management tools forms a robust framework for optimizing the titanium hinge bracket production. Quality and lean management tools helps to shift the manufacturing process from a reactive inspection to a proactive defect prevention, where it integrates with advanced digital systems that enhance the effectiveness of lean. Moreover, quality and lean management tools also impact in the production excellence as it improves the product quality and reliability, and it enhances the performance efficiency and manufacturing of titanium hinge brackets as it reduces the defects and rework processes in the production line. That's all from us, Doctor. Thank you.